Number 134 in your classwork for coordinate proofs asks you to find the coordinates of point C in terms of M and N. So here C is going to have the segment CD is going to have the same slope as AB in order for it to be a parallelogram, so opposite sides must be parallel, and they also must be congruent. So this means that the change in x from D to C, so this value, this delta x must be the same delta x as this from A to B, and same goes for the delta y's. So this delta y must be the same delta y as delta y from A to B. So that'll give the same slope, and it'll also give the same distance covered. So this delta y is equal to coordinates of by, so that's 2n minus coordinates of y of a, so that's n. So that gives us change in y of n. So from D to get to C, we need to add n to the y coordinates. So y coordinates of C are 0 plus n from, so this is from D, and we're just adding n, so that's n for the y coordinates. And for the x coordinates, our change in x is from the x of b, so that's m, minus x coordinates of a are m minus n, which gives us a n. So also to the x coordinates of d, so we're adding an n, which gives us an x coordinate of m plus n for our x of c. And so now we want to prove that ABCD is a square, and we can do that by proving that the two diagonals of the square are congruent of the same measure. So if you prove that the line going from B to D is the same length as the line going from A to C, and also that they intersect at 90 degrees, they will make a quadrilateral ABCD a square. So we're going to do this. So the segment of AC is given by distance formula. So AC, we can say, is the change in x squared. So that will be C. So that's m plus n minus the x of a, so that's m minus n, all that squared, plus the change in y squared. So the change in y is actually the same, so it's n and n, so that's just a 0 squared. So we're looking at only this one term. This is squared and to the square root, so that will cancel. So AC is just m plus n minus m, then minus and negative n, so that will be plus n. So these m's cancel, and AC is given as a length of 2n. Now we want to prove that BD has the same length. So since it is also a vertical line, so there's no change in x, we can just look at the change in y. So we have a change in y from 0 to 2n. So the length of BD is also going to be 2n. So the diagonals are congruent, and we want to look at their intersection angle. So line AC has a slope of 0. Since there's no change in y, this is n. Y coordinate of C is n. So if this is a horizontal line, and BD, since there's no change in x, is a vertical line, then they will intersect at a perpendicular angle. So AC is perpendicular to BD, and AC is congruent to BD. So therefore, we can say that ABCD is a square.